Previously, we looked at a program that computed the area of a circle using the formula pi r squared. We were looking at that formula in terms of how pi is to be declared as a constant. Now I want to look more at the formula itself and look at some varying ways to do that. So if we write out the line of code to compute the formula, we have pi times radius times radius. Then we can display the answer. The area of a circle with radius 3 is, move outside the string, area, and a new line. Build and run the program, and we see that the answer is 28.2743, and I have to believe that's correct. Now, the problem with this program is there's a more efficient way to compute the radius squared rather than just multiplying it by itself. And that's using a built-in function power that's part of a library called the CMath library, which provides us with a whole range of advanced mathematical functions to use in our programs. So if we want to use this power function, we have to first #include the CMath library into our program, like so. Then, where we've written radius times radius, we'll take that out and write the math function pow, which stands for power, in its place with its arguments. The first argument is the number we want to raise to a power, and the second argument is the power we want to raise, the value 2. Type a semicolon, that should be it. We build and run, and we get the same answer, 28.2743. In your programs, when you have the opportunity to use a built-in function, whether it's in the math library or any other library once you become more of an expert C++ programmer, you should use those functions. They're more efficient. They've been tested over and over again, probably millions of times, so they're thoroughly debugged and work quite well. Let's look at some other examples of some math functions that are part of that library. I'm going to comment out the code that we've already used. One good example is the square root. We'll just do some very simple calculations here. So we're going to compute the square root of 144, because that's an easy one. We know the answer to that. Hit build and run. We see that the square root of 144 is 12. So that's one example. Another function that's used quite a bit is the absolute value function. So for example, we can compute the absolute value of 1,345 and compute the absolute value of negative 1,345. Put an inline this time so we can have a little space there. Let's build and run the program. We see that the absolute value of a positive number is itself, and the absolute value of a negative number is the positive, or the negation of that negative number and the positive. So there's another example of a nice, handy built-in math function. Let's look at yet another one. The modulus operator we looked at previously works with whole numbers only. So for example, if I try to do 23.45 modulus 3, and compile and run that program, I have an error where I tried to do that computation because the modulus operator works only with whole numbers. The solution to that problem is a built-in function called fmod. Run it like so, build and run, and you see that the remainder is 0.23. So the math library gives us a solution to do modulus operations on floating point numbers when we can't use the built-in modulus operator with that type of number. Once again, let me emphasize that the math library should be used anytime you need the functionality that's provided in the library, even if you can recreate that functionality using primitive methods like I did with squaring and cubing numbers earlier. The math library functions are much more efficient. They've been debugged over and over again, and they're preferred in your programs.